Okay, hi everyone. So in this video, I'm gonna solve these problems. So you are asked to determine the force in member DG, yeah, DG, this member, yeah, and also member GH, this member, okay. So you need to state if the members are in tension or compression. So there are two methods how to solve this. First is that you can use method of joints, and the second one you can use the method of sections. Yeah. For the DG, because the location is far from the boundary conditions, so the the relevant choice should be by using the method of sections, right? And for the GH, you can either use method of section or you can also use method of join. Yeah. So let's do DG first. Yeah. So first, what you need to see that this is a rigid trusses. Yeah. Uh, so you need to first draw the free body diagrams. Okay. So how to draw the free body diagrams? Let's draw the free body diagram. I'm not good at drawing, but here you see, because you have a roller there and then the roller slides on the y axis. Yeah, so this is the x and this is the y, so it means that it can slide in the y but not in the x, so there should be a reaction force in the x axis. So you need to be careful, yeah, because some students made the mistakes. They're putting IY, instead they have to use IX, yeah, instead of IY. And then at point A, because it is a pin joint, you should replace it by two forces, AY and AX. Okay, and then there is 6 kilonewton forces downwards, and then there is 4 kilonewton forces downward. Okay, and this is point I. Okay, so this is the free body diagrams. So to make complete, you can put dimension if you want. Yeah, so this is 0.3 meters and this is 0.3 meters too. Yeah, and then I guess uh, this is 0 0.4, 0 0.4, 0 0.4, and 0.4 meters. Yeah. So by looking at this, it's 0.3, 0.4 means that uh, it has a 3-4-5 relationship by Pythagoras. Yeah. For the diagonal, for example, if this is 0.3 and this is 0.4, means that this trusses is 0.5 meter. Yeah, and I hope you understand that. Yeah, so I don't have to explain again. So let's focus on the free body diagram. You completed the free body diagram, then what you need to do is to find the ix. Yeah, to find the ix, because we want to make a section and then we want to take the right part, the right side of the trusses. You can take the left side of the trusses. It's up to you. It's just a personal preference. Yeah. So what are we going to do since we want to find Ix? So we need to use the equilibrium equations. Take sigma moment at point A. So sigma moment at point A equals 0. Yeah. Sigma moment at point A equals 0 means that all these forces at point A will not generate any moment, but 6 kilonewton, yeah, they will generate a clockwise moment. Yeah, so minus 6 times this distance, which is 0.8, and then you have minus 4. Why? Because 4 will also generate a clockwise rotations, uh, times what? I guess it's times 1.2. Yeah, because 0.4 plus 0.4 plus 0.4. And then this ix with that directions that we wrote down, because it's the assumption, yeah, will have what we call a counterclockwise rotations with the length of 0.6, yeah, because the distance from this to this is 0.6, yeah. So plus ix times 0.6 equals 0. Okay, so you have this equation, you can solve, yeah, you can divide by, I don't know, 0.2. So you have 3 here, you have 6, and then you have 4. So then you have minus 24 plus 3ix equals 0, right? So if you put minus 24 and then minus 24 to the right side, you will have ix equals 48 divided by 3 kilonewton. Ix means 16 kilonewtons, and they are positive, means that the directions that we assume in the beginning, the ix, the direction of ix is correct, yeah. Okay, so let me mark with color red, since this is important findings that we may refer later when we calculate. Okay, that is ix. So you finish free body diagrams, and then you finish finding ix, and then what we need to do is to make to find dg, yeah, by using method of sections. How to solve that? We make a section like this, yeah. Okay, so let's continue by kiting ix. So yeah, that's the shape. Let me redraw again. Okay, and then that is ix, yeah, and then here we have force. What is the force? FGE, and then we have the force FDG, and then we have the force FFD, right? And I think that is the sectioning of this one, right? Am I right? Yes, I think I'm right. And then there will be a force of, I'm not sure how much is that, 4 kilonewtons. 4 kilonewtons. Okay, so first sectioning. Okay, and then what we need to do is that after we make the first section to find dg, what are we going to do? We need to make the same thing. Yeah, we need to apply the equilibrium equations. So the equilibrium equation for this part is what? Can we solve that? I think we can solve right away for dg, no? Because yeah, if you take a look at this, sigma Fy, sigma force in the y directions, only 4 kilonewton, and dg, yeah, because those are the two forces that work in the y direction. So let's calculating sigma Fy equals 0, yeah. So you have minus 4, right? And then you have FDG in the y directions. How to project the FDG? So basically what you need to do, I will put different colors, yeah, to show the projection of this, yeah. So it should be minus, yeah, f dg cos theta. This is the theta, okay. Is in this case cos means this 0.3 and then 5, 0.5. So it's a 3 over 5, yeah. And then that's it, right? For the vertical. And then they're equal to 0. And then what else? FDG equals minus 4. You multiply by 5 and divide it by 3, which means that they are, how much is that? It's minus 20 divided by 3, or it's minus 6.66 kilonewton. Yeah, so that's FDG. Yeah, FDG. Yeah, let's mark in red. Let's box it in red color. Yeah, so if you draw that member, if you draw that FDG member, yeah, the direction is negative, means that the assumption is wrong. So it should be, with respect to the joint, it will be like this. This is the correct directions, 6.66. Yeah. It's okay. So this is point I. This is point, I'm not sure. Yeah. This is point D. Yeah, so the member will be in compression. Yeah. So negative here means compression. Yeah. Because the way I solve this problem, I always make the assumption out of from the point. Yeah. Going outward from the point. So I always assume that all the assumed forces is tension. So when they are negative, they will be in compression. Okay. I think that's for FG. I hope it's clear enough for you. So FDG 6.6 and they're in compressions. So the next question is GH, yeah, GH. So now let's calculate GH. There are two ways to solve GH. Let's solve here, I guess. Okay, and then there is IX, right? IX, and then there is a force FIG, and then there is FGH, right? And then there is a force FH. So IH we know, and then we have three unknowns, yeah? So how to solve this? This is basically you're making a sectioning here, right? Sorry. You're making a sectioning here. So this is what you got, right? So from the second section, okay, we need to apply the same thing, yeah, because all of about statics is just applying equilibrium equations. So here, let's take moment at point H, yeah. So point H, yeah, sigma, wait a minute, my pencil is problematic. Sigma m at point H equals 0, yeah. So what you got is that basically Ix, imagine we apply a point here, it will create a positive moment times 0.3. And then what else? We will have plus Fig and, but not Fig itself, but the horizontal component of Fig cos theta, which means 0.4 divided 0.5, 4 over 5 times the distance, which is also 0.3 equals 0. Am I right? I think I'm right, right? So you can delete this, and then Fig equals Ix. How much is Ix before? I forgot. 16, which is 16 times 5 divided by 4. So it's 20 kilonewton. This is Fig. Yeah. And then okay, that's it. Okay, what else? Now, what are we looking for actually? Oh, this is what we are looking for. Yeah. So it is on the x direction. Oh, it means that we need to find FFH again. And then let's do, since we already know Fig, now we take a look at sigma Fy equals 0. Yeah. This is the second equilibrium equations. And then you will have minus Fig times this one, yeah, 3 over 5. The vertical components will be like this, right? So 3 upon 5, yeah, the projection Fig. And then you also have FFH minus FFH, the same thing, 3 over 5 too, I guess, right? 3 over 5 equal 0. Is there any vertical component again? No, right? Only those two forces. So FH, yeah, if we remove this, they are equals to minus Fig, which is 20 kilonewton. Okay, so we have those forces, FFH and Fig. Okay, and then the last equation, the x equations, right? Sigma Fx equals 0. I have minus Ix because it's to the left, right? And then I have Fig cos theta, which is 4 over 5. And then what else? I have FGH, right? Minus FGH, the one that we are looking for. And then I have FFH, FFH cos theta, which is the same thing, 4 over 5. And then they're all equal 0. Okay. So Ix is minus 16. Ix is 16, right? So it's minus 16. FIG minus 20 times 4 over 5. Okay, minus FGH minus FFH minus 20, and then 4 over 5 equals 0. Yeah, so if we, this is 4 and this is 4, so we will have minus 16 minus FGH, and then plus, because double minus here, plus 16 equals 0. So this cancel. Yeah, this cancel. So F, oops, sorry. Let's make it black. FGH equals minus 16 kilonewton. Yeah. So again, FGH is in compression. Okay, so this is that you are looking for from the second section. And if you ask me, sir, how to draw the free body diagram of that members, yeah, so basically, yeah, if we go again here, let's say this is point H, yeah, and then there is a point G, okay, point G, and then in between you have the member, yeah, so FGH is, by initial we put to the left, but then the result is negative, so it should be to the right, or with respect to member it's to the left. Yeah, so you see here it's it's compression, okay, which is minus 16. So this is the results. Yeah, so both the members in questions are in compression. Okay, and I hope it's clear enough, yeah, for you. But the most important thing is that first, when you have a question like this, you need to be able to draw the free body diagram. Free body diagram is a global structure, yeah. So draw a global structure like this, and then try to replace the support with the reaction forces, depending whether they are roll, or if they are pin, yeah. Okay, and then find the reaction forces, and then in this case, since we want to take the right side, what we need to find is IX only. We don't need to find AX and AY, yeah. But if you want to solve this by taking take a look at the left side, you need to find AX and AY. In my case, I take the right side, so I only need to find the IX, yeah. Once I get IX, I made sectioning, yeah. I need to do two sectioning. The first sectioning, I do this one, and then I get what I want, FDG, yeah. And then for the second section, yeah, this is the, where is it, yeah, this is the second section, yeah. And then I use equilibrium equation. I did 3 times for the moment, for the y direction, and for the x direction, and then I get the FG is the force in GH member, and both of them are in compression. Okay, I hope it's clear enough. Let me know in the comment section below if you have any questions. I will try to upload more videos like this regularly, because I know many of my students, they need to practice a lot, and then sometimes they are unable to understand while they are in the classroom. So I will put this kind of videos regularly on my YouTube channel. See you.